glad to see you. I hope you are all doing well. So, as you might have noticed with watching the Simplifying Radicals video, if you watch that one first, we're going back to review some things that have to do with radicals before we get into our next section that has to deal with special right triangles. So today's work and tomorrow's work will deal with radicals, and then Thursday and Friday we'll concentrate on special right triangles, but you have to do radicals when solving special right triangles. So that is the reason for this review work, and some of it is new material as well. If ever there isn't enough information for you in my videos, feel free to Google the subject and find more videos on YouTube. Just know that many of the videos on YouTube that have to deal with simplifying radicals don't all simplify radicals the way that you were taught to do that from Mrs. Verallen, or even the way that I've shown you to do it while we were in school or in our videos that we've been doing. So don't hesitate to always go out and find more information if you need more information, but just understand that they may not all teach the same way that we have taught. All right, so you're going to find out that there will be times when you will be multiplying radicals together and then also dividing radicals. So one whiteboard has problems with multiplying radicals, one whiteboard has problems with dividing radicals, and we'll get this started. One thing that I can say is to always make sure that I would suggest that you simplify before you multiply. When you multiply, you're going to make your numbers bigger. In order for them to be in simplest radical form, you got to bring them back down to their smallest form possible anyway. So if you simplify them before you multiply them, you may not end up with large numbers that you have to worry about, okay, now how do I simplify this? For example, if it's okay to multiply two numbers together that are in both inside of radicals. So I want to do the square root of 12 times the square root of 32. If you multiplied first, you'd be taking the square root of a number that is over 320. That's probably 384. Okay, if you don't easily know the factors of 384, that's going to be very time consuming. So I'm going to simplify before I multiply. Now I'm going to be going through the simplifying process pretty quick on a lot of these. I'll do it on here quick. If you watched the other video from today, you would have been reminded about simplifying radicals. So if I break 12 down to its prime factors, I should get down to 2 times 2 times 3. So what I'm going to do in the rest of this video is try to quickly just go through those prime factors without writing out the tree every time. Okay, so 2 times 2 times 3. And also, since we're multiplying, it's okay to put both numbers that you're multiplying by inside of the same radical. So instead of writing two separate radicals, it's okay to write one big radical. 32 is going to be 2 times 2 times 2 times 2 times 2. Okay, so now what I want to do is look for my pairs of factors that match. The square root of 2 times 2, I'll be able to take the square root of that. Another pair of 2 times 2, and another pair of 2 times 2. So the square root of each of these is going to be 2, but I am not able to take the square root of 3 or the single 2 over here that's all by itself. So that will be 6. And 2 times 2 times 2 is 8. So 8 times the square root of 6 is what I would get if I multiplied the square root of 12 by the square root of 32. You can check all of these on a scientific calculator, a calculator that will do square roots. If you wanted to, you would do the square root of 12 times the square root of 32 and see what that comes out to be. And then type in 8 times the square root of 6 and you should get the same results. All right, the next one, I've got numbers on the outside of the radicals, numbers on the inside of the radicals. So basically it's kind of like a like term sort of thing. For example, if I wanted to do 3x times 6x, I can do 3 times 6 and get 18, x times x and get x squared. So it's okay for me to multiply the numbers that are out in front of the radicals and the numbers that are inside of the radicals in a similar way that I can do 3x times 6x. But remember, like I said here, rather than doing 14 times 42 and making this really large number, it would be best if you simplified those numbers first and to see if you can take the square root of any parts of them. So I have 2 times 7 for 14. I know that 42 is 7 times 6, so I'm going to do 7 times 2 times 3 because 6 is 2 times 3. Again, do the factor trees on these if you don't know those factors off the top of your head like I do. Okay, so I can do a 7 times a 7, which that will come out in front in a little bit. I've got a 2 times a 2, so that is going to come out in front also. And the only thing that's going to be left inside of the radical sign is the 3. So 2 times 7 times 6 times 3. I don't know if I'm prepared to do that. Let's see, 42 times 2 is 84, and 3 times 84, 240, 252, I believe. Yes. So 252 multiplied by the square root of 3 is as simple as that radical can get. Okay, and then just another practice. This number doesn't have a number in front, but we would anticipate that it's a 1. So even though this one does, and this one didn't at first, it's still 3 times 1 or just 3. And 7, the square root of 28 is, or 28's factors are 7, 2, and 2. Because that would be 4 times 7, which is 28, and then I have the 7 from this square root. So square root of 7 times 7 is going to be 7. The square root of 2 times 2 is going to be 2. There's nothing left inside of the radical sign, and that will happen, and it can happen. And so when I multiply these together, I should get 42. So it is possible that when you multiply... Thanks, Rika. That was my dog. Sorry about that. It is possible that when you multiply your radicals together, that you will get a whole number. All right. Dividing radicals. Again, it is okay to keep them separated. Oops, let me zoom out here for you, which requires just me moving my whole tripod. Okay, it is okay for you to keep your radicals separated in your problems. It's also okay to put them together into a fraction. So I'll show you both ways. What I'll do is I'll separate them, but eventually they're going to go back into a fraction together anyway. So let's do the square root of 72. So its factors are 3 times 3 times 2 times 2 times 2. And 18, 3 times 3 times 2. Okay, so I would say probably the best way to look at this no matter what, instead of having it as a separate radical in the numerator and a separate radical in the denominator, go ahead and put them both underneath the same radical sign. Okay, so now this pair of 3's simplifies to a 1. This pair of 3's simplifies to a 1. A pair of 2's that simplifies to a 1. So I'm left with the square root of 2 times 2 over 1. 2 times 2 over 1 is 4 over 1, and the square root of 4 is equal to 2. Okay, back up here, maybe from the beginning you wanted to look at it as just one fraction that you're taking the square root of. 72 divided by 18, if you guys are good enough with your factors, you maybe already know that 18 goes into 72 4 times, and the square root of 4 then is 2. But if you don't know your factors well enough, you might not just jump right into that fact right there. And that's fine. That's what your factor trees are there for. Getting you numbers that are easier for you to work with and easier for you to simplify. All right. 27 goes into 54 2 times. So if you're good at your factors, you might write it like this. 54 divided by 27 is 2. Still inside of the square root, and I can't simplify it because there is no perfect square root for 2. I would just leave it like that. And you'd be done, and there's nothing wrong with that. But if you're not up on your factors and you don't know that 27 goes into 54 evenly, then you would do a factor tree on 54 and a factor tree on 27, and you can put them all inside the same radical sign. So 54, 3 times 3 times 3 times 2. 27 is 3 times 3 times 3. Pair of 3 simplifies to 1. Simplifies to 1, simplifies to 1, and there I am left with that square root of 2, which should stay in the numerator because that's where it's at right now inside of the radical sign. It's in the numerator of that fraction. You're going to see in our next video for tomorrow, rationalizing the denominator. We're not supposed to have square roots in denominators anyway, so lucky for us, this 2 ended up in the numerator. All right, hopefully that helps. There's some practice for you out there to give a try. Good luck.